Now let's look at the graph of our reciprocal functions. Here we're talking about the cosecant function and the secant function. We know that the cosecant of x is equal to 1 over sine x. So whenever sine of x is equal to 0, we're going to have it undefined, so we'll have a vertical asymptote. We know sine of x is equal to 0 at 0, pi, 2 pi, 3 pi, pi, negative 2 pi, negative 3 pi. So here we have our basic sine function. Wherever our sine is equal to 0, we have a vertical asymptote on our cosine function. When we graph our cosecant function, it will be the reciprocal of our sine function. So here, when sine is equal to 1, the reciprocal of 1 will be 1. And here, as the sine gets smaller, the cosecant will get larger. So we have our cosecant function looking in this direction. Similarly, we'll have our cosecant down here, our cosecant here, our cosecant here, here, and here. For secant function, we know secant is equal to 1 over cosine. So whenever cosine is equal to 0, we're going to have a vertical asymptote also. We have cosecant equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2, and so on. So at these points, we will have vertical asymptotes. We know that when the cosine of 0 is 1, so the inverse of 1 will be 1. And as the cosine gets smaller, the inverse of that will become larger. So we have our secant function looking like this. So our secant, the inverse of the cosine function, will look like this. And in general, it's always easier to graph our basic function and then do their inverse. So to draw the cosecant function, we graph the sine function and draw the inverse of it. To draw the secant function, we draw the cosine function and do the inverse of that. In this example, we're going to look at the graph of y is equal to 2 cosecant of x minus pi. As we mentioned before, it's normally easier to graph the inverse of a cosecant function and then graph the cosecant function. We know the inverse of cosecant is sine, so this is the equivalent of y is equal to 2 times 1 over sine of x minus pi. If we graph the inverse first, we have y is equal to 2 sine of x minus pi. From this, we know our amplitude for the sine function is 2. We know there's a horizontal shift. We find our horizontal shift by setting x minus pi equal to 0 and x minus pi is equal to 2 pi, since we know the period for a sine is 0 to 2 pi. Solving for this, we have x is equal to pi and we have x is equal to 3 pi. So our graph is shift pi units over, so here we go from pi to 3 pi for one complete period. And here we have the sketch of one period of our sine function. I've also included many other period of this sine graph. So here we go up to 2, this is our amplitude, so it's from 2 to negative 2. We have 0 to 2 pi, that's one period, 2 pi to 4 pi, that's another period. Now let's look at the vertical asymptotes. We know where sine is equal to 0, we have a vertical asymptote. So at negative 4 pi we have a vertical asymptote, at negative 3 pi we have a vertical asymptote, at negative 2 pi, vertical, negative pi, 0, pi, 2 pi, 3 pi, 4 pi. Sine all these in this function will give us 0. Having graphed that, it's now a matter of just drawing the inverse. The inverse will be on the top like this. So here we go. This is our required graph. and on the top. So the graph of y is equal to 2 cosecant of x minus pi is actually all of this and all of this. It's just the inverse of our sine function. So once again, draw our sine function to graph our cosecant function. Now let's get a graph of y is equal to negative secant pi x plus 1. To graph our secant function, we graph the reciprocal function, which is cosine, and then we draw the inverse of that. So the inverse of secant reciprocal function would be negative cosine pi x plus 1. So we're going to go ahead and draw the inverse of this, which is negative cosine pi x plus 1. We know our period for a cosine function is 2 pi over pi. 2 pi over b, and here our b is pi, so it's 2 pi over pi, which gives us a period of 2. So for one complete cycle from 0 to 2, we'll have our cosine function. We know the amplitude is 1, since the coefficient here is negative 1, and we know the amplitude is the absolute value of a. This has a vertical shift of 1, so we know our cosine function will shift up 1. So now let's just try and sketch this. Our original cosine function with a period of 2 will be this dotted line starting at 1, going down negative 1 and back up to 2. So this is our cosine function from 1 to negative 1, back up to 2 because our period is 2. We however know that here our coefficient is negative. So instead of being 1, it will be reflected in this direction. So this actually ends up looking like this. But because of the vertical shift, even if it's reflected down, it's going to be moved up 1. So here we have our negative 1 cosine pi x plus 1 function. Period of 2, flipped over and shift up 1 in blue. So here, this is this function. To graph our negative secant pi x plus 1, we'll put in our vertical asymptotes, which is negative 0.5, 0.5, 1.5, 2.5, and 3.5. All we need to do is to put our points in here, lines in here. So here, all this is our negative secant pi x plus 1.